Hello, everyone. I know that the three of us are standing between you and lunch, but we are talking about a very important topic today that contains a hopeful message. According to Food and Agriculture Organization of the United Nations, global agricultural production needs to increase by 50% till 2050 in order to feed the world's growing population. However, the amount of arable land decreases, and that's why new and more efficient strategies are needed. There are various approaches, for example, vertical farming and the cultivation of algae for food production, what we are talking about today. Macro and microalgae are considered a promising addition to food supply for humans and livestock, and more consumers avoid animal protein and opt for plant and algae-based products instead. Furthermore, macroalgae are very important for pharma and cosmetic industry. So we have a very exciting market here, and it could also contribute to solving a problem that we don't even want to believe still exists, that in 2024 there are still people starving in this world. And I think in a world with so many brilliant minds and ideas, as we see once again here at DLD, this is something we shouldn't accept. So I'm really happy that we have two men with us who are active in this field and can tell us more about the challenges and the potential of the spirulina microalgae production. Please give a warm welcome to Alexander Gerfer, CTO of Würth Elektronik, manufacturer of electronic and electromechanical components for the electronics industry, which is active in 50 countries. And we are happy to have Martin Havers with us, a systems engineer and founder of the project development company Agile Solutions. As part of a collaboration, Agile Solutions and Würth Elektronik developed a LED light system that significantly increases yield and automated production of high-purity microalgae and terrestrial plants. We will have a look at this in some minutes. As you see, Alexander and Martin brought something with them, but first we'll start with a little introduction. Alexander, can you tell us what attracts you to this topic?
Yeah, very welcome. Thanks for having me at the DLD. I'm coming from a farm, a small farm, which does not longer exist because it was too small to survive. So we have the land still, we rent the land to other farmers. But of course, the thing, how to produce food, how to feed 2 billion more people by 2050 is a challenging task. We see it actually outside the streets, how emotional this is also discussed. And in behind is, of course, the need for more precise, more productivity in food production in existing and new ways, of course. And algae is one of the new ways. So this thing, how can we trigger this, is, of course, personal motivation in behind of this. Yeah, how do we do this? And the need is there. And as a manufacturer, we can say, as we have a nice part out of this solution, we take this responsibility and want to drive these things further.
Martin, what brought you together with microalgae?
Yeah, okay, it's a funny story. Some years ago, a friend and former colleague gave me a call and told me about his new investment in a planned microalgae farm. Yeah, and he asked me for support, but no wasn't an option for him. So I took the job, great, and I was responsible for design the whole factory, for the automatization, trails, and optimization of an already existing concept reactor of the factory. And due to this, I spent a lot of time in northern Germany at an algae guru, and at this algae guru there was a concept reactor. And I never dreamed that I dive so deeply into the matters of a microalgae and its photosynthesis. But for me, it was a great challenge as systems engineer to bring technology and biology together. And ask myself, what are the habits of a microalgae? What do they need, and how can I tickle them that they accelerate their growth? The tests were really great, and we were able to make a lot of optimization to raise the technology level of the concept reactor. But one thing happened. We recognized that the plant lighting system was too weak and inflexible. And this was a point where Würth Electronics came into the game. We know us already since years, but I don't recognize that. Okay, I know that they have technology in the LEDs, what I don't know to this point that they have a biologist for horticulture, lighting, and the support and the field applications engineers was a great support to develop a new system, the lighting system.
Alexander, could you tell us a little more about the experience that Würth Electronics was able to draw on here?
Yeah, as I said before, we are originally a hardware manufacturer, so you see the lights lighting up there. These are the things we talk about, the LED itself. So this is one thing, we manufacture these kind of components, but the most important point is now, as I said, this thing of how to feed the world, how to find solutions, is also a need for adopting these kind of LED to be more precise on coloring, on wavelengths we call it, on powering, and so on. And this is where we learn from such kind of examples and are willing to adopt this. And we could already gain and put in some of the experiences we had from the vertical farming, which we have presented here several times before in different solution stages. And overall, this technology is so, where we find so interesting that we want, as a manufacturer, take this responsibility, as Würth Group, as Würth Elektronik Group, to raise the awareness about this new type of food production as one masterpiece or one puzzle piece, say, in the whole solution game of how to feed the world. Yeah.
You were already talking about the corporate responsibility for such a topic. And also to support innovation at a very early stage. So what kind of support can Würth offer to startups especially, or very small projects?
Yeah, good. I had my own experience when I was young. I'm quite old now. Also, I had a startup which we wanted to do based on a hardware solution, and we could do the first round of piece we presented. We could have made tons of money. But in the second approach, we had to build another 10 pieces of equipment. And then we learned from the supplier, no, you cannot get it, you are too small. Buy 50,000 pieces and then you can get it, but not in the time you need, in 6 months plus. And the next round of presentation was in 6 weeks. So we lost the business. Good, I'm sitting here now because of this, but in this case, is what reality is. Hardware startups need a special support. And for a hardware startup to go fast, it needs collaboration. That's what we offer, especially in this field of special knowledge needed on the LED typo, so that I, as a hardware startup, because algae production means more than only light, I can concentrate myself on all the other topics around and get the best support from a crazy manufacturer like Würth Elektronik, even going into a niche and not fearing the niche to go and support this and raise the awareness for such kind of solutions. So we support startups hardware technology-wise from the beginning, and even we do not know where it ends if it comes to really super mass productions later on, but hardware needs a good support, let's say it this way. Yeah.
Talking about the challenges for startups, so we are at DLD here, and the motto is Dare to Know. What does that mean for you in this sense?
Of course, willing to learn, also be open, be curious, what we say, learn new things. That's what we encourage people to do. Of course, and then courage to take action. And that means in a company like us to say, no, we go this way. We invest, and that's what Reinhold Würth is pushing us, do crazy things, long-term lasting things. So growing food is a long-term, it's a family-owned business. Normally when you go to farmers, a long-lasting business, it needs especially long-time support. And that's where we are strong in. We can give this support. And of course, the most important point is share the knowledge. Don't sit on your knowledge alone like on a tower. No, share your knowledge and speed up this process of hardware solutions into the market.
Yeah. So hopefully lots of knowledge is shared here as well.
Hopefully, yes.
So it's hard to overlook. You already brought an outcome of your collaboration with you. So if you have a close look, you can see the algae grow right while we are talking. Martin, could you tell us a little more about, for non-experts, how this works?
Sure, I will try. Okay, in front of the stage, you see a simple version of a laboratory reactor. For spirulina, it's a type of microalgae. And at first, the spirulina is an expert in producing proteins and secondary plant compounds like phycocyanin. And these are important for markets for food, animal food, nutrition, also as well for cosmetics and pharma. And with similar reactors, you are able to produce chlorella. It's an expert in fatty acid, omega-3. So you have different kinds to produce important stuff for the different markets. Now back to the reactor. Simplified version mean this is without actuators or sensors to measure CO2 conversion. It's related to the growth of algae. But we have what you can see between the tanks is a lighting system. And this lighting system is very specialized and can mix light together. This is like a bartender at a cocktail party. And you can the bartender mixes the right blends of blue, red, white, and other spectral nuances together to generate a feel-good atmosphere for the algae, so that it's healthy and can grow. For example, blue and red is very important for the growth and CO2 conversion of the algae. White and other nuances you can use for the health of the algae, but also to forces dedicated secondary plant compounds. And especially with the secondary plant compounds, you can deliver this to cosmetic, pharma. And there's an additional very important point I want to mention to you. To deliver this, you have to ensure that you are able to deliver this 365 days per year under under purest conditions. So the algae must be the highest degree of purity for these markets.
Yeah.
And yes, and the last what you can see in front of the tanks are the bubbles. This shows you the presence of an air venting system, also an important topic. To deliver CO2, we are able to enrich CO2 to force the growth of the algae and raise the output of the factory.
So they really need the light to feel comfortable. Is there something you want to add on the light system, Alexander?
As said before, light is very important, plays an important role here because each plant, each algae reacts different to the lighting content of blue and red, at which time of growth. So we call this the so-called light recipe. That has to be understood. So we enforce and we support these kind of researches, so how to trigger these points, how to adopt the right light recipe over time with rich colors and LED. And as said before, we can make this feedback loop back to our LED production to see what else is needed. Are we on the right colors, also wavelengths, technology spoken, or do we have to adopt something here? And this is where we go in this collaboration, as mentioned before. So we can have here a close communication. We can concentrate and solve this issue on the lighting system. We offer for other startups, of course, special already demo kits where you can do with an app your own researches on lighting applications. That's how we came across to this and to our contact. So that is where we are strong in, where we support in. Yeah. And that is a really interesting thing. And of course, this production technology of LED is not so simple as it looks like. So we go into this niche again and support fully. Yeah.
So now, as you know how to grow them, what's the market potential and what are the challenges in doing this, in scaling?
Okay, yeah, in scaling, for my point of view, an important point is to do a holistic approach. You have to look at a lot of different points, and for this you can use maybe model-based approach, and later you can enrich those kinds of approach with AI, for example. But at first you have to understand with this holistic approach, what is the purpose of the farm? Is it used for food production, for nutrients, for cosmetics, and for pharma? And in the combination with the pre-testing, like on those kind of reactor, how the crop or algae grow, then you are able to do the scaling of the technology. Look at a big farm you want to build. There are difference in climatization. If you do this for crops in different levels, you have to ensure the same temperature on each level, the same humidity, the same lighting, and this is the biggest challenge for this, especially for this upscaling factor.
And for markets, we see already the algae is not so rarely in the market. It's already existing. But as said before, the grade of purity is questionable, let's say it this way. And in these closed systems, you can fully control its super high purity inside. The water we use is clear, where the water comes from, and so on and so forth. So that's really one of the most important points here. And the markets, what you see is then you have an ability to replace the old traditional way of growing algae, this is new technology with more output, more throughput, more productivity. And at the same time, of course, as we've seen before, proteins or pharma usage or whatever is a new market evolving. And underlined by 2016, the European community did now officially name algae as an agri produce. So they are already permitted to go as a food into the market. And now it's up to us to go and to grow, so to say, and make it reality. And then have the right partners already having this knowledge in behind and supporting this setup of such kind of factories, optimized for what you want to do, medical, omega-3 things or whatever. That's what we can, or he especially can offer. Absolutely.
I want to add two important topics. The one topic is that we're able to do this in a closed environment for algae or like vertical farms in a clean room area. This is one of two enablers for this cosmetic and pharma markets.
Absolutely.
And this additional topic to do this indoor is we can deliver 365 days per year. That's not possible with all
traditional ways. Absolutely.
Right.
Correct.
So when talking about potential for the future, it's sometimes interesting to look at the US as well. And I know, Alexander, that you just came back from the Consumer Electronics Show in Las Vegas. And it would be interesting for us to hear a little more about what challenges do they have for farming, for farmers, and how are they related to new technologies.
Yeah, it's interesting to see that the CES show in Las Vegas opened this year, the first time ever, an agriculture tech panel over a full afternoon approach was very diverse setting, even from financial guys were sitting there to farmers, everything was there. And the interesting story is you come back home and you open the newspaper and you discuss in Germany the income of a farmer, and whereas in US they talk about a different approach. They talk about average age of the farmer, which is a family-oriented business, long-term running business. Average age of a farmer in US is, what do you guess? 57 years, and 1/3 of them is over 65. And they have a big issue now to motivate young generation going into this still not so romantic, it's really hard work farming. And what they say and what they really push is AI as a supporter, so going into the full autonomous tractor, so to say, in a full autonomous harvest robot. We presented robots also last year with a berry harvesting robot. And so this is really where they say we have to adopt things to attract young people to see farming as a high-tech approach now. And coupled with AI, you have the power, first time ever, to look at each and every crop individually, because you can do this visually at the edge with edge computing. Don't have to send it in the cloud. Later on you can do and send the results into the cloud. That's what they drive to force into and to cover with this robot approach also there. So that's the same problem as here. Do we have enough people doing the harvest later on? They had to give up a huge field in a state in US, and their fields are way much more larger than our fields because they didn't have last year people for harvesting. That is really a disaster to have this in the field. So their challenge, or they were really pushing young talents, go and see farming as a high-tech approach. It will change, because what will not change is the climatic things happening, the calculation of my output, so to say, but AI and all the things together can ensure your volatility of output is under better control in this farming, and it's really a high-tech job. It's not as before, and automation comes into the game. And of course, then the second approach was about venture capitalists. Please don't exit after 2 years. It's a long-running business. I was sitting in the audience, was like, what? They talk about 20 to 30 years. So stick and stay with them. If you invest, it takes longer to get the revenue done. But growers are passionate people. They don't give up this business. It's a 24/7 business all the day. If you have to go up in the morning 5, you go up in the morning at 5. It's everyday work, and that's what they say. And of course, here comes everything together. That's what the tech firms and we try to do again to empower this with collaboration, so support as we can and where we can to get these things done and to attract people, young people. We have the same story here in Europe. It's not only a US problem, to go into this field of it's a technology-driven business, farming of the future.
Yeah. Not so much to do with the romantic picture we sometimes have here. That's true, but very interesting. So thanks a lot for sharing. Thanks a lot for the interesting insights, Matt. And I'm really curious to see how much more algae will find entrance into our daily habits and also our eating habits. Yeah. So thanks a lot for your attention, and in that sense, enjoy the lunch.
Thanks.
Okay. Thank you very much.